Hello and welcome back to our presentation. We are team 영재꿈나무 and I'm back to inform all of you about our new advancement with our Akalama version 2.0, specifically the AkaCLS that we developed. Our team still consists of Park Seung-ho, Shim Soo-min, Kim Chae-eun, and Shin Ji-won. Our table of contents is as follows. I'll start by reminding everyone about our research topic, limitation of related works, our research method. Then I'll be talking about the results and limitations of our newly developed classifier and our future plans going forward. So the goal of our research is to produce high quality data sets for a Korean LLM with the most efficient method. We produce these results using custom-made prompts and classifiers that were made in-house, producing one of the most accurate Korean LLMs made in Yonsei University. Llama 3 is one of the most advanced LLM that was created in Meta this spring. And this newly made LLM could be used both in 8 billion or 70 billion parameters. It even excels from other LLMs such as Google's Gemini. While Gemini, GPT-4o, and Claude are all closed source, Llama 3 could be flexible to individualistic needs and could be fine-tuned to be used commercially. The only drawback comes from the fact that it excels in English and should be fine-tuned to have similar results in Korean. The graph on the right shows the performance of Llama 3 70 billion instruct by comparing with other models like Claude Sonnet using human evaluation. The Akalama version 1.0 was made with Meta's Llama 3 70 billion instruct model, fine-tuned by Mirror Lab's publicly available curated datasets. Akalama version 1.0 outperforms other LLMs that were made by other Korean companies, though it has some limitations mentioned below. So firstly, with a model of only 70 billion, there were insufficient data to perform a quantitative evaluation. Secondly, no specific benchmarks were considered during the dataset construction phase, and the model was trained purely on deduplication. Thirdly, any previous Korean datasets relied on machine translation, which in turn produced unreliable quality. To summarize our research proposal, firstly, from Akalama version 0.1, with small amount of data, LLM's Korean ability can be awakened. Secondly, with well-performing classifier, we can get high-quality Korean datasets efficiently. Lastly, we'll make high-quality datasets from internet-scale mass data using classifier and fine-tuning Akalama using the data. Our research method looks something like this, and this is our overall architecture of our research. For our first step, we compare prompting methods with SOTA models. We compared EN versus Ko, which is English versus Korean, and zero shot versus few shot for the most optimal prompting method, and GPT-4o mini versus Gemini 1.5 Pro for the most optimal SOTA model. For our second step, we compared GPT-4o mini and other open source models to find which one is the best suited classifier for our use case. For all the steps, first and second, we generate QA, a pair evaluation with models, and generate human benchmarks. This is done by choosing which one is better between Model 1 and Model 2. After that, we apply the ELO ranking system designed by RPAD ELO to find which model or combination works well. For step 3, we distill the knowledge of the best open model in step 2 to a smaller classifier to reduce computational costs. I'll be going over this more in depth in a later slide. When it comes to collecting data, we used AI Hub and Hugging Face to gather an abundant amount of data, specifically QGenPy's K-Open Platypus and Biomi's Co-Alpaca version 1.1a. To determine the best prompting method, we generated the evaluation of QA pair by GPT-4o Mini and Gemini 1.5 Pro. This is shown in the picture provided in this slide. After that, we made human benchmarks with consideration focused on educational value, fluency, and how natural their Koreans are, and contextual consistency between question and answer. As mentioned before, to evaluate the ranking between the computations, we utilized the ELO ranking, which is widely used for players in zero-sum game, to determine the best prompting method. Here's the code for ELO ranking. The prompting method we used is as follows. Firstly, we experimented with the language. Languages for prompting, so we observed the models prompting in English, starting with ENG, generally have higher ELO scores compared to models prompted in Korean, starting with KOR. Secondly, we experimented with few-shot learning. And the results are that the models without few-shot learning, marked as N, generally have higher ELO scores compared to models with few-shot learning. We made our own classifier because the best open model, the Quen 2.5, was too large for a classifier. So we made 500K QA score paired dataset using the best open model in step 2 and trained our classifier to distill the knowledge of the best open model. We made our classifier model using a frozen embedding model and score module. For the embedding model, we chose BGE Multilingual Gemini 2 because this embedding model is trained with Korean datasets. For the score modules, we experimented between linear and non-linear MLP model, which predicted scores within the range of 1 to 5. We also experimented between ordinal regression loss and MSE loss. The number of QA pair and the evaluation sets are as follows. So we did two benchmarks. The first one we did had a size of 3,336 pairs, and the second had a size of 3,375 pairs. For the first step, we found that the prompt method with English and zero shot is better than GPT-4o mini. For the second step, we found that open source model Quen 2.5 72 billion instruct was the best. And here's the graph of our results. So the first graph is a nonlinear graph of both normal and MSE data. The second graph shows a linear graph of normal and MSE. We can see from the graph that nonlinear has the best performance. And to explain the graph in a further detail, this graph has a validation split of 5%, which means for every epoch, we calculated an F1 score. Since our data has labels from 1 to 5, the F1 score combines both precision and recall, making it the most optimal metric to use. Now I'll be going over some limitations that we've experienced. Our main limitation was within our classifier. Due to the bias of original data distribution on scores 4 and 5, the model does not match score 1 really well. And this results can cause a low score incorrectly evaluated as a higher score. We've noticed this limitation and plan to overcome this in our future plan. Now with the future plan. Because of our dedication to our current project, we'll be working on this even after this semester ends. And here are some of the things that we'll be doing. So firstly, we'll be looking into using internet scale data and filtering internet scale Korean data sets to fine-tune Akalemma with high quality training data. And secondly, we'll like to create a mobile app or web application and train our model in order to be suited for Yonsei University. So especially when it comes to any academic or school-wide information, our LLM could be used. For now, we'll be ending our presentation here. Please feel free to ask any questions, and thank you everyone for listening.